And now, the James Webb Space Telescope is identifying objects in the dark ages.
The James Webb Space Telescope has made a significant discovery at the edge of the universe. Astronomers using the telescope have found 6 massive galaxies that existed between 500 million and 700 million years after the Big Bang. This discovery challenges previous beliefs about galaxy formation and has revolutionized our understanding of the early cosmos. The findings were published in the journal Nature. The James Webb Space Telescope has exceeded expectations by discovering unexpectedly large galaxies in the early cosmos. Scientists were surprised to find fully developed galaxies similar to our own when they had anticipated only small and newly formed ones. This remarkable telescope utilizes infrared light to observe the universe, allowing it to detect faint light emitted by aging stars and galaxies. Consequently, it can provide us with a glimpse into the distant past, approximately 13.5 billion years ago, by observing the far reaches of the universe. The recent discovery of massive galaxy formations challenges established scientific beliefs about the early universe. These extraordinary galaxies, which we playfully call universe breakers, have surprised researchers by their enormous size and early formation. This finding calls for a re-evaluation of current theories on the origins and evolution of galaxies, since they contradict around 99% of existing models. Previously, it was believed that galaxies began as small clusters of stars and dust, gradually evolving over time. However, by observing the early universe, scientists were astonished by the unexpected magnitude of these galaxies, which has sparked a need to reassess our understanding of galactic development. The unexpected discovery of massive galaxies poses challenges to scientific understanding. When high-resolution images from the James Webb Space Telescope became available in July 2022, researchers were surprised to find these galaxies. They initially doubted their interpretation of the data, but soon confirmed their existence using spectroscopy. This discovery was not anticipated and occurred earlier than expected. The discovery of these galaxies through the Webb data raises the possibility that they may be something other than galaxies. Given that this is our first glimpse into such early cosmic history, it is important to maintain an open-minded approach to our observations, although the available data strongly indicates their identification as galaxies. It is plausible that some of these objects could be concealed supermassive black holes. Notably, the estimated mass of stars during this period in the universe's history is now believed up to be 100 times greater than previously thought, which remains a significant finding. Through the utilization of data from the James Webb Space Telescope, an international team of astronomers has confirmed the existence of the oldest and farthest galaxies to date. These galaxies date back to a time fewer than 400 million years after the Big Bang, when the universe was merely 2% of its present age. By detecting light emitted by these galaxies over 13.4 billion years ago, similar to previous observations with the Hubble Space Telescope, the JWST has identified a number of potential galaxies. Subsequently, through extensive spectroscopic observations, 4 of these objects have been verified, enabling astronomers to study their physical characteristics and accurately determine their distances. Astronomers can also calculate a galaxy's redshift to determine its distance from us. Redshift observations suggest the universe's expansion, causing light to stretch to longer wavelengths. Spectroscopy confirms redshift measurements, and recent discoveries focus on 4 distant galaxies with high redshifts. 2 of these galaxies have redshifts of 10.38 and 11.58, while the other 2 have redshifts of 13.20 and 12.63, indicating their immense distances. The James Webb Telescope's instruments, including the NIRCam, played a crucial role in these findings. The JADES program involves over 80 astronomers and aims to deepen our understanding of the early universe. The JADES program dedicated more than 10 days to observe a small region of the sky, including the Hubble Ultra Deep Field. Astronomers have been studying this area for over 2 decades, and the JADES team made a remarkable discovery. They identified nearly 100,000 galaxies located billions of light years away. By examining the field using 9 different infrared wavelengths, these scientists collected light from 250 weak galaxies in just 3 days of observation, thanks to the NIR spectrograph. These measurements allowed them to reveal the properties of the gas and stars within these galaxies and obtain accurate redshift values. With this information, we can determine the intrinsic brightness and stellar content of the galaxies. By unraveling the evolution of galaxies over time, we can better understand their growth from the early stages. Just like humans, the initial generations of stars have a profound impact on subsequent events. This is an incredibly exciting time in history as we are gaining transformative insights into the nature of galaxies thanks to the James Webb Space Telescope. Around 225 million years after the Big Bang, the formation of some of the earliest stars began. It is estimated that star formation in these young galaxies commenced approximately 100 million years before their discovery. NASA's Deep Space Observatory telescope is playing a crucial role in providing us with a new and unique perspective on the cosmos. There is a wealth of exciting discoveries awaiting us as we continue to pioneer scientific research. The James Webb Space Telescope has provided remarkable new insights into galaxies, planets, stars, and various cosmic phenomena. Launched in December 2021, this telescope is expected to operate for 20 years, offering a long-lasting cosmic journey. Serving as a successor to the Hubble Space Telescope, Webb sets new standards for scientific enthusiasm, with people worldwide eagerly sharing its raw data, photos, and gaining fresh insights. It's important to note that while Webb was not the first telescope to directly image an exoplanet, it has made numerous other amazing discoveries. Developed by NASA scientists and engineers over years of hard work, Webb's successful launch on Christmas Day 2021 was followed by the flawless deployment of its various components in the subsequent months. By mid-July, Webb unveiled its stunning initial images, enabling us to observe every aspect of our universe, including the most distant galaxies, with enhanced clarity using its infrared capabilities. Shortly after the telescope became operational in late June 2022, scientists began discovering thousands of previously unknown galaxies which are older and located farther away than any previously known ones. The James Webb Space Telescope has made significant discoveries that surpass Hubble's oldest findings by more than 150 million years. Its powerful capabilities allow it to gather enough light from celestial objects like exoplanets and newborn stars to unveil their composition and trajectories in space. By analyzing faint light signals from the early universe, Webb has provided detailed insights into the atmospheric composition of planets located hundreds of light years away, offering clues about their potential habitability. Furthermore, the telescope has potentially identified the oldest black hole known in the universe, a supermassive black hole with a mass 10 million times that of the Sun. This cosmic monster resides at the center of a young galaxy that formed 570 million years after the universe's inception. Webb's advanced cameras enable it to peer back in time to the earliest moments of the cosmos, shedding light on the growth of black holes during the cosmic dawn, a billion-year period beginning approximately 100 million years after the Big Bang. However, the reasons behind the abundance and remarkable size of these black holes remain mysterious to astronomers. Some of these immense cosmic phenomena, known as active galactic nuclei or AGN, emit light observable by telescopes due to the heat generated by material spiraling into them. Supermassive black holes, or quasars, billions of times more massive than the Sun, unleash incredibly bright light blasts, surpassing the brightness of even the most luminous stars. By probing deeper into the cosmos, scientists can access light from earlier eras, thanks to the constant speed of light. Webb's instruments, including the mid-infrared instrument and near-infrared camera, along with their spectrographs, played a crucial role in detecting the black hole. Analysis of the light spectrum revealed faint traces of radiation emitted by the heated material surrounding the black hole, providing insight into the universe's early stages. However, the rapid appearance and proliferation of black holes in the young cosmos still pose unanswered questions. Webb's fascinating discovery includes the exoplanet WASP-39b, which orbits a star in the Virgo constellation. This gas giant, similar in size to Saturn, is located about 700 light-years away from Earth. What sets it apart is its exceptionally close proximity to its host star, orbiting at a distance approximately 8 times closer than Mercury is to the Sun. Webb's capabilities have allowed for extensive research on this exoplanet, making it one of the most studied outside of our solar system. Hey, that's it for today, but please make sure you subscribe to our channel for more exciting content. And thanks for watching.